the examples of commercial SSPS model currently studied in Japan. So JAXA and the USEF and METI studying the feasibility of SSPS, making the model of commercial SSPS. So this model was made by USEF and METI. METI is the Ministry of Economy, Trade and Industry. So this model is called a basic microwave type model. So in this model, the one side is solar array, and in opposite side is the antenna of transmitting energy by microwave. So in this system, the side of the antenna must be pointed to the earth. So in this system, the system cannot get the solar power for 24 hours. But the next model is advanced microwave type model made by JAXA. So this model has a large reflector. This one is this one. So using reflector, so this system can get the solar power for about 24 hours. So third model is laser model. So in this model, so many units of laser generator were connected like line. So each unit can transmit the energy of laser. So now we are studying the feasibility of this model. So next, I show the verification matrix towards commercial SSPS. So finally, we aim at the commercial SSPS of 1 gigawatt. So in order to realize commercial SSPS, we try to make the plan of demonstration mission phase to phase. Now we try to carry that ground demonstration. So power is about a few kilowatt. So the distance is about 100 meters. So next step is the demonstration mission using demonstration mission on orbit using small satellite or GEM. GEM is a Japanese experiment module on International Space Station. In this mission, the power of transmitting energy is 1 kilowatt. So the altitude is low Earth orbit. The mission of the purpose of mission is to investigate the effect of ionosphere and the atmosphere transmission. So next phase is a large structure. So in this mission, the large structure must be constructed on orbit. So the power is about 100 kilowatt. So the altitude is low Earth orbit. So in this mission, small rectangle is on ground. So this rectangle can get the power of 10 kilowatt. So next mission is a small plant. So in this mission, the power is about 2 megawatt. The altitude is 1,000 kilometer. So in this mission, so the large rectangle can get the 2 megawatt of 100% of the transmitting energy. Okay, so before a commercial SSPS, we have planned to demonstrate a verification plant. This mission, so this satellite is on orbit of geostationary. So distance between the transmitter and the receiver is about 36,000 kilometers, so long. So in this mission, the kilometer size of large structure must be constructed on orbit. So in this system, the power is 200 megawatt. Of course, the large rectangle can get the 200 megawatt, 100% of transmit energy. So next step is the commercial system. So this image is our proposed roadmap of SSPS. This roadmap has a three-phase: research phase, development phase, and commercial phase. So in research phase, so we have planned to carry out ground demonstration and small-scale on-orbit demonstration using small satellite or Japanese experimental module. And 100 kilowatt class on-orbit demonstration. So in this research phase, we have planned to select select the type of energy, microwave or laser, and we have planned to select the configuration of satellite system. So the next phase is development phase. In this phase, so we have planned to make the bigger system of SSPS. So we have planned to carry out a 2 megawatt class demonstration and 200 megawatt class plant. Finally, so in commercial phase, we have planned. We aim at the realization of 1 gigawatt class first commercial model around 2035. So in our target, we aim at the commercial SSPS of practical use in around 2040. This is our roadmap of proposal. So next, I showed the experiments of transmitting energy. At first, I showed the microwave power transmission experiment on the ground. So this is the image of transmission experiment on the ground using microwave. So in our spec, so the antenna of transmitter is the size of antenna is 1.6 meter times 1.6 meter. So this antenna has 4 panels movable to each other. The power of transmitting is 2.8 kilowatt. Frequency is 5.8 gigahertz. The efficiency of changing from electric power to microwave is more than 40%. And the microwave beam control is retrodirective control using pilot signal from rectangle side. And the size of rectangle, which is a receiving system, the size of rectangle is 2.5 meter times 2.5 meter. And this rectangle has 72 modules. So DC conversion efficiency is more than 17%. And the distance is about 100 meters. So now we have planned to carry out this transmission experiments in 2014. So next is the image of laser power transmission experiments on the ground. So in this spec, the laser output power is 1 kilowatt. So wavelength is 1.06 micrometer. So the range of transmission is 100 meter. A beam control is several microradian. So receiver output power is 0.2 kilowatt. In fact, so about 3 years ago, the laser power transmission experiment was carried out. But so this facility is near the area of big earthquake. So earthquake happened, and this facility was damaged. So now we don't have plan to carry out this transmission experiment again now. So next is the experiment for assembling large structure of SSPS. This is the image of test on the ground. So this structure has the panel unit for antenna and power generator, this panel, and the truss structure of deploy and connection. So in the fairing of launch vehicle, so a panel and truss structure are folded like this. So on orbit, so this structure is deployed and connected next of structure. So repeating the deploy and connecting this structure again and again. So at last, we make the large structure like this. So this experiment will be carried out in 2014. So next, I show the two possible platforms for SSPS wireless power transmission experiment in the near future. So one image is efficient launch vehicle for small satellite. So next generation solid propellant rocket to reduce the cost by third of that of the former M5 launch vehicle. First flight will be 2013. So one platform is the Japanese experiment module, the GEM, we call Kibo, on the International Space Station. This is for science and technology research mission extended for 5 years. So now we have studying the demonstration mission on orbit using this rocket or Japanese experimental module. So now we are studying the demonstration mission on orbit. So one of candidates of demonstration mission is microwave power transmission experiment from small satellite. So the orbit of this mission is low Earth orbit, 370 kilometer. The satellite weight is 400 kilogram, and the mission weight is 200 kilogram. So transmission power is 3.8 kilowatt. But in this mission, so antenna is too small to receive enough power on ground. So the purpose of this mission is to investigate the effect of ionosphere and atmosphere transmit. Next mission is microwave power transmission experiment from GEM. Okay, so panel size is 2.4 meter times 2.4 meter. So frequency of microwave is 5.8 gigahertz. So output power is 8.64 kilowatt. Even this mission, so antenna is not so big. So the receiver cannot enough power on ground. So the purpose of this mission is the same of the small satellite. So next mission is laser power transmission experiments from GEM. So this mission, so in this mission, the power of transmitter is 1 kilowatt. The wavelength of laser is 1.06 micrometer. So diameter of laser beam is 20 centimeter. Okay, so divergence of angle is 15 microradian, and the pointing accuracy is 1 microradian. So receiver on ground, the beam size become 10 meter of diameter on the ground. So receiver on ground can get the power of 200 watt according to our estimate. So the converter for laser beam to electric power, so we can use a photovoltaic cell array we use. So next, I showed the laser power transmission possible application for lunar exploration. So JAXA is studying the exploration of water ice in crater on the moon. So in this mission, rover find the water ice in the crater. So of course the rover needs the electric power, but in the moon, the half of month is night. So even at night, the rover must look for water ice in the crater. So laser SSPS can supply the energy to the rover. And not only a rover, but also lunar base can receive the electric power from the laser SSPS. So laser SSPS can contribute the lunar development. This is the image of the lunar development. My presentation is finished. Thank you. The antenna must be pointed to the Earth. So in this system, the system cannot get to the solar power for 24 hours. But the next model is advanced microwave type model made by JAXA. So this model has a large reflector. This one is this one, trade and industry. So this model is called a basic microwave type model. So in this model, the one side is solar array, and in opposite side is the antenna of transmitting energy by microwave. So in this system, the side of the examples of commercial SSPS model currently studied in Japan. So JAXA and the USEF and METI studying the feasibility of SSPS, making the model of commercial SSPS. So this model was made by USEF and METI. METI is the Ministry of Economy. So using reflector, so this system can get the solar power for about 24 hours. So third model is laser model. So in this model, so many units of laser generator were connected like line. So each unit can transmit the energy of laser. So now we are studying the feasibility of this model. So next, I show the verification matrix towards commercial SSPS. So finally, we aim at the commercial SSPS of 1 gigawatt. So in order to realize commercial